what the fucking horizon is, bro?
It's Earth curvature.
Yeah,
So it's Earth
it's the
curvature,
abutment of the sky and the land.
Yeah, so it's an apparent junction, right? So it's not physical?
It's the Earth's curvature is what it is.
So it's an apparent junction caused by Earth curvature or eyesight?
Earth curvature and the refraction of however much land you can see beyond the Earth's curvature.
So it's not just Earth curvature, it's refraction too. So you want to keep going?
No, that's it.
So if it's refraction, if it's refraction, that means it's not physical?
No, that's not what I said. I said it's the Earth's curvature
Plus refraction, right?
Yeah, refraction is going to allow you to see a little bit more, a little bit less of it.
So it's not a geometric edge then because of refraction.
It's the edge of the Earth. It's a curve. It's not the edge of the Earth, but it's the curve of the Earth.
Right, but for refraction, you just said refraction makes me see farther or
it'll
closer.
allow you to see further or not as far, depending on the day. Yeah.
So not Earth curvature then. It's refraction.
So this is where I disengage.
Well, I'm just trying to clarify your answer. 1 minute it's Earth curve, 1 minute it's refraction. Can you be more specific?
Let's see how smart you are, Flare Data. This is a real.
No, you're now you're reversing it, eh? Nice try, bud.
It's the curve of the Earth. The Earth is curving away from you, and there's going to be things obstructed from that curve. On the top of that, you're going to have refraction, which is going to refract the light coming from things beyond the Earth, or obstructing the things in front of you, cause you to see less of it. So you're going to see more or less of the extent that you can see from the curve of the Earth.
Awesome. So the junction is caused by what then? The clouds touching the ground. That's caused by what then? Or appearing to touch the ground. Was it caused by that?
Said it was Earth curve and air.
Okay, so it's Earth curve and air that causes it. Copy that. Anything else, Kosho? Earth curve and air. Okay.
It's pretty straightforward.
Scott, I have you as well. What causes the apparent junction of the sky and ground? Earth curvature or eyesight?
The abutment of the two things. It's the same thing that causes the apparent junction between the side of a building and the sky.
Okay, so it's the same thing that causes the apparent junction of the sky and ground. What is that? What's the same thing?
Abutment of the two materials.
The two materials. What's those two materials?
The ground and the sky. The ground and the air are abutted. When we look at them, they're abutted. We see them abutted. Now, why are they abutted, or why are they abutted right there? There's other answers to that question, but we perceive them as being, a junction because there's nothing in between the two things.
So you see a junction because there's nothing between the two things, but then they're butted together.
The air and the ground are butted.
But they're butted together, right? They're butted together because there's a junction. Because what?
I told you. There's nothing in between them. That's what butted means, right? So
nothing
in between them. So there's butted to each other. So you look at the distance. What are you going to see between them? But nothing. Okay, so that's why they appear to be junctioned.
So nothing's in between them.
It's the same reason why the water and the ground is abutted or junctioned. It's the same reason why the sky and the side of a building is junctioned.
Because there's nothing in between them.
Because they're touching, they're overlapping, and there's nothing in between. Yeah.
So they're touching and they're overlapping because there's nothing in between them.
Yes. Why do you keep repeating what I've just said back to me?
Just to clarify,
the
apparent junction there has nothing to do with your eyesight.
Nothing to do with my eyesight? Why would it have nothing to do with that? Didn't I just say something you use your eyes to see?
Well, you said there's no.
How would you do what I just said without eyesight?
You said that nothing is in between it.
Well, how would you know that if you don't have eyesight?
Well, I'm just saying this is what you're saying, right? Nothing is
between
it. I know,
but I'm just asking you why you asked if it has nothing to do with eyesight.
Is it eyesight causing it? Is it eyesight causing it, or nothing in between them that's causing it?
Well, does eyesight cause what you see, or is it facilitate what you see?
So it's eyesight that causes it then?
No, I said, does eyesight cause what you see, or does it facilitate what you see?
So your eyesight has a limitation to angular limit to objects, right?
Why are you avoiding the question I just asked you?
Well, you're
avoiding the question.
Does your eyesight cause what you see, or does it facilitate what you see?
So your eyesight has a limitation to the angle of light. So that angle of light converges, causing a junction. You'd like to say that junction is physical.
That's not an answer to my question. You asked me, is it caused by my eyesight? And I'm asking you, does eyesight cause what you see ever? or does it facilitate what you see?
Everything that you see has to go through your eye to see it.
Yes.
What we have is perspective, what causes the refraction of the ground to appear to rise. It doesn't actually rise, right, Scott?
The what of the ground? The refraction of the ground?
Your eye refracts light up into the neutral point of the eye.
No, incorrect.
Oh, it doesn't?
No, light is refracted by all kinds of things.
Okay, so your light doesn't bend into the eye?
It bends in the eye, but it bends in other things too.
That's refraction, right?
Yeah, you made it sound as if the eye is the only thing that can refract anything.
No, you're saying that. I'm talking about our ground.
Anytime light passes between two mediums of different densities, it's going to refract. It's going to bend towards the medium that's more dense.
Do you see how hard you're struggling here, to be honest with me? Do you know that I have you on record? Do you know I have you on record already claiming that perspective causes it, and now you're changing your position?
Perspective doesn't cause anything. Perspective is involved, though. Why would you cause perspective causes?
Perspective doesn't cause anything?
No, what does it cause?
Your angular limitation?
No, your angular limitation is a fact over and above your perspective.
So your angular limitation is what? Above and below my perspective? What? What did you say?
For example, your perspective exists, right? That is essentially the way in which you perceive the distance to objects and the way in which their size changes based on their distance. Okay, is that reasonable for you?
So the ground rises
the
because
angular.
Hold on. Curvature or
the angular resolution you can perceive has something to do with that, but it also has something to do with, well, what does your brain process? How much can your brain distinguish? It's not purely a function of perspective. Your perspective doesn't cause it. Your perspective is part of the process.
So the ground rises because of earth curvature or because of perspective?
The ground appears to rise as you look at it because of the way perspective works.
So not earth curvature, right?
The ground does not rise because of earth curvature, no.
Right. So at 3 miles for a 6-foot observer, the ground is appearing to rise. It's not actually rising, right?
It's actually dropping.
Okay. So if I have 2 observers 3 miles apart from each other looking at each other, the ground is appearing to rise and converge in between both.
It's actually dropping away from both too.
You hear what he's saying there, Data?
Yeah, I know it's terrible, dude. It's terrible. Yeah.
You just don't understand. We've been over this before. I have you on record for having asked questions before. You got the same answers last time. You just misunderstand how this works.
So I'm misunderstanding perspective. Okay. So I have you on record already saying
I have you on record.
Perspective causes the horizon, and now I
never use the word cause, so you clearly wrote it down wrong.
So you already understand the ground is not really rising; it's only appearing to rise, and the only way to get refraction is you need what? What do you need to get refraction?
Different densities in your mediums.
Awesome, but you need straight lines of light to enter that medium to bend, right?
You just need light to enter it. I mean, it's going to be moving straight when it does.
Right. So if the ground is appearing to rise, and then it's not actually rising, that means the light is being. The
ground is not rising.
Can I get it out, guys? Can I get it out?
Just relax.
Don't get
it
relax. I'm really relaxed, bro. I don't know if you can.
Okay, well then why are you over talking me, dude? Just let me answer your question.
I think you're interrupting me over and over again, right?
Refraction data. It rises because of perspective. Those are two different things, right?
Right. What causes your perspective?
Distance, your brain, your eyes, the distance to the object.
Light bouncing off the object, being refracted into the eye past the circular aperture.
That's the refracting into the eye part is not so much the key.
So, okay, I asked you this before. What causes? What does a convex lens make?
Which one is convex? The one that.
So when
convex in which direction?
Does light diverge or converge in a convex lens?
Which one is convex though? I don't know this. Which one is convex? Is it the light hitting the outside of the arc or the inside of the arc?
So the human eyeball is convex, and when light,
convex. So it's gonna when it hits the sides, they're gonna bend inward. So they come to a
converge,
point.
Right? So the convergence point, right?
Yeah.
So it's optical. The convergence point is optical, correct?
Yeah, everything in your eye is optical.
But the convergence point is caused by what? Earth curvature or eyesight? You told me it was earth curvature.
No, I didn't say anything about convergence point. What are you talking about?
The apparent junction is the convergence point, my friend.
It's not. No, it's not.
That's why it's an apparent junction. No, the sky and ground is not touching, Scott.
look, all this light goes into your eye. Now, you could, if we drew a line on the ground, a horizontal line in front of you, that's not a convergence point when you see that line. Now, if I take the line and I paint, a big section of the ground a color, I'm going to see a junction between the colored ground and the not colored ground. The same thing as the horizon. If I build something on top of the ground, I'm going to see a junction between the building and the ground. Same thing as the horizon.
Yeah, but
he was talking about a line you draw. He was talking about the horizon.
No, I'm just using it as a metaphor.
Yeah, I'm not. So
the horizon
the only way
is the horizon is just a apparent line in what we look at.
The only way to get a refracted line the only way to get a line to refract, it has to pass through a medium.
The line is not refracting.
Let me finish. The light from the light that's going into the observer's eye is refracting and producing a convergence effect, which there's a junction of the sky and ground as the cause of it. And how do we know this?
This is all wrong.
Okay, so how do we know this?
This is wrong.
Are you going to keep interrupting me?
I thought you were asking me, you just asked me, how do we know this? And my answer is, it's wrong.
Sorry, let me rephrase myself. When you look out into the distance, you already established the ground is not rising. You, in fact, say that it's dropping away, is what you say.
Right.
How does refraction work?
With respect to what?
Just in general, what do you need for refraction to work?
When light moves from one medium to another, if the two mediums have different densities, it will cause the light to appear to bend. And the reason it does this is because of the constant speed of light. And so as it hits one medium, it essentially has to bend towards the more dense side in order to keep up. Basically,
according to refraction, what is the refraction index of air?
I don't know, probably like I'm going to guess like 0.6.
It's 1. It's actually equivalent to the vacuum of space. So
I thought one was water.
How does 1.33 is water, 1 is air? So how I could be wrong with that actually, but 1 is air. So if air is quantified as 1 due to the refraction index, that means light is traveling in straight lines, right?
No, because it doesn't mean that all air is 1, because the density of the air is what really matters. So what they must be saying when they say the refraction index of air is talking about some sort of average for it. But if you have
focus,
hold on. If you have sections of air in which they're significantly different in their density, then they will not have the same refractive index.
So how do you get refraction? You need a straight line of light, would you say?
Light to enter into that barrier.
So you would need a straight line of light to get refraction, right?
Technically, it doesn't have to be straight because it could be bending continuously due to refraction as it moves into this next area of density. So if you think in terms of continuous math, that it could be curving, really.
Okay, so when you look at perspective, is the light hitting our eye coming in straight, or is it coming in bent?
Coming in straight.
So that's why the ground appears to rise and it doesn't, right? Because everything is straight lines. But because we have
the reason why things.
Let me finish, dude.
Ask me a question again. You keep asking questions. You don't really need to be asking, I think.
So the light enters our eye is coming in a straight path. But it appears that the ground rises because as the light enters our eye, it converges into a point. Just like our perspective shows, there's a convergence point or a junction point. You want to see an extreme version of that convergence, look down a long hallway. It doesn't take 3 miles. Let me finish. It doesn't take 3 miles to converge down a hallway because there's smaller angles. When you have larger angles, you have a farther, a stretched out convergence point. This is demonstratable. You can force perspective. You can do all this stuff to show how smaller angles will produce a faster convergence. The point is, the convergence isn't actually happening. It's only an optical effect based on the angular limitation to the eye. That's why the ground and the clouds appear to touch, because it's based on the angle of light bouncing off the object, coming back into our eye, creating a convergence point.
There's a lot of incorrect
example.
Oh my God, you're still
example
going?
Is two observers. Now, I'm sure you can understand.
There's like 3 things you've said wrong now. I'm going to lose track.
Something you already said. You got to make shorter points, man.
Take some notes.
So I'm going to give you an example that you can do in real life. Go in public, 3 miles apart from each other, and look at 180 at each other, and you'll notice there's a apparent junction between the two of you. But because of perspective, not earth curvature, there is actually no junction there. That means the lines of light are actually straight between both observers, but because perspective converges it into your eyesight, you think that's earth curve, and it's not.
Such an
It's
idiot.
actually
Data, come on.
That's not an argument. That's not an argument.
Can we start unpacking all your mistakes you made? So please do. Okay, so let's start with one of the most egregious ones. You keep talking as if this apparent junction that we see between the ground and the sky is a refractive phenomenon, but
it's an angular limit. It's an angular limitation, my friend.
That's what Kosho just said. Kosho just said it was refracted. Just so you know, so that's your argument, guys.
It can be refracted, but that's not the reason why we see the junction. The horizon can be refracted. That's a given. Anything can be refracted.
Perspective is caused by refraction.
Perspective is made a long ass point. Let him finish.
Your perspective is literally caused by refracted light.
Perspective is caused by refraction? Come on.
So it's not caused by
perspective.
It's not.
Your perspective
I'm not
literally
explaining where you're wrong. You got to let me finish, otherwise you'll never hear why you're wrong. So what I was saying, there was something different. You started to interrupt to go on to another point. The point I'm making right now, though, is this. You think that this apparent junction between these two things isn't actually there. There's no junction. You think it's a refractive effect. But the truth is that the junction we see, that horizon we see, actually is there. The air, the sky, is actually abutted against the ground. They are actually junctioned. They're touching each other. That horizon that we see is actually a physical thing between molecules of air and molecules of ground. So you should remember that first and foremost.
The sky and the ground touch.
They do.
You got that? Are you recording this?
They do. I don't know what to tell you, dude. They do. So that's one.
Dude, are you recording?
So here's the next thing.
The sky and the ground touch.
He heard you. You got to record it because you guys think you guys have a point, but it's the truth. So record it, listen to it, mull it, and eventually you guys will realize it. So second thing is,
so the clouds in the distance on the horizon are touching the water.
Clouds in the distance on the horizon.
The clouds in the distance that appear to converge at the horizon where the kiss happens.
I haven't seen it.
The sky and the water kiss.
I've never seen clouds on the actual horizon. If you've seen something like that,
you've never seen clouds in the distance over the water.
I've seen them above the water, but not touching the horizon. But it may be possible. If that's the case, I can tell you what
you're saying. That's what you're saying.
The sky is touching the horizon. But I haven't seen the clouds touching the horizon.
You kept using the word abutted.
Yes, the sky, not the clouds. The sky. The clouds are stuck up about they can't go lower than I think it's I forget. There's some height.
The sky's above the clouds though.
The sky's below the clouds too. The sky is everything the air is. The sky exists right in space.
Below the clouds now.
Are you hearing the
yeah, flat Earth math. Flat Earth math tried the same thing and he ran off and he has.
I have no idea what question. To me, the sky is a synonym for the air around us. When we walk outside, you breathe the sky in. You look at the sky.
This is how simple it is.
Hold on, dude. Let me finish what I'm saying. You went on for so long, dude. I haven't even gotten to point 2 yet. So you can look everywhere you look, you can see sky. You can see air. That actually touches the ground, right? You don't have a problem with that. The air touches the ground touches the air, right? So when you look in the distance and you see sky touching ground, you're seeing air touching ground, which shouldn't surprise you.
This your argument? That's your argument?
No, I have a lot of arguments. We barely even got started.
So
you guys keep interrupting. Your show is taking a long time, though.
Scott, you just
no. You made 4 points. It's my turn to talk now. You have to listen.
Okay, but
so here's the second thing that you got wrong. You keep talking about this perspective effect as being some sort of convergence in your eye, and you think that's somehow important. But the way perspective works is that the light coming into your eye comes in at different angles, correct? The light that's directly in front of you at your eye line is going to come in directly straight. And the lines are straight, but they're coming in at increasing or lower or decreasing angles. So the things that are coming in at a very extreme angle are going to be perceived closer to you, lower than the things that are coming in at a less extreme angle. So the reason why the ground appears to rise is that if you draw a line from the middle of your eye to some point on the ground, you have to keep changing that angle. If you want to draw the point farther and farther out, that angle has to become less and less steep or less and less dramatic. And so all the way into the point where you get it looking straight ahead. And since all that stuff is collecting at once, and you lay it down onto, like, say, a flat plane in the back of your eye, which is really a curve, but you can do it on a flat plane, you'll see that, oh, look at that. The ones that come in higher than the others, that come in at the lower angles, are going to end up being higher than the ones that come in a more extreme angle. And that's why you end up looking like, or that's why you get this phenomena of things appearing to rise as they go further away.
So just to clarify, the angle from the object at your feet is a different angle from 3 miles away, right? Right? As you look off into the distance, though, that angle to that object is not actually rising, but only appearing to rise, right?
No, it does rise.
Angle changes.
It does rise. The angle does narrow as the object gets further and further away till it gets to eye level.
So here's an example, boys. If I have a fire red truck at my knees and it's 4 feet tall, right? Big red fire truck, 4 feet tall. As I move away, that object will appear to go upward, right? As it moves away.
Yeah, because the angle
are changing.
Okay.
The angle to the object will change trigonometrically to be larger.
I'm not talking to you, Zanuck. I'm not talking to you. So, Scott, as that red fire truck moves away from us, it'll appear to move up. Are the angles of light straight to my eye from that truck?
Depends on which, that phrase is ambiguous, because the angle into your eye changes.
So they're straight, right? The lines of light bouncing off that.
Move backwards.
The angle of light bouncing off that truck is entering my eye in a straight path. As it moves away,
at an angle,
as it moves away, it'll appear to rise up into the central neutral point of the eye, but it actually isn't rising up, right?
Angle.
It is actually rising up.
Okay.
So it's going uphill.
There's something called trigonometry.
Are you hearing?
Angle changes as it gets further away.
It's really terrible, man, how disingenuous these guys are. So
I don't know what your problem is. So the angle is changing as you move backwards. Do you understand that part?
Okay.
Because as you move back, you're going to need a less and less steep angle to get to the object.
Okay. Right? Here's an example.
You understand that part, though.
Here's an example for you.
If you don't understand that part, no wonder you don't understand it.
Yeah. Listen.
The angle changes and it looks like it's rising. It's still at your feet level, but it looks like it's rising because the angle is physically changing.
2-on-1?
Listen,
am I debating 2-on-1?
Stop talking.
You have to answer questions. So you pick and then answer questions.
Yeah. Go on.
So do you understand the angle changes as you back up? That's all I'm asking.
So angles always change, but they're entering in your eye straight. They're being refracted into a cone. A cone angle. So let me finish. I'll give you a better example. Okay. Here's something you can visualize. Maybe you're having a hard time understanding my point. So I'll just clarify. Let's say we had two big fire trucks. One was 5 foot, and we had another one above 5 feet separated. So we had one below and one above, dividing our vision in half. Let's say. Now those fire trucks moved away. At some point, they'll appear to touch each other, but they won't actually touch, right?
I get it depends on how you move them away, but there's definitely situations.
Depends how I move them away.
Hold on, let me ask the question. There are situations where things are overlapping each other.
No,
I don't think I would not call that
how
appear
you
to
move
touch.
away.
I would not call that appear to. Hold on, I would not call that appear to touch, but that is overlapping. You keep saying. Hold on, you keep saying that things converge to a cone, but that's not true. Your eyes, everything does not converge to a point when you look at things. It does not.
So
and in fact, it crosses over the plane of that cone you're talking about and makes a upside down reverse image on the back of your retina.
Yeah, and your brain flips it over. So listen, let me try it again.
So then why do you call it converging on a point then?
Because if you look at how it enters in your eye and how it comes to a focal point, okay, that's what it does.
And then beyond a focal point, right?
Going out, we have a focal point. Coming in, we have a focal point because we have a refraction,
which means we move past the focal point before we see it, right?
Are you interrupting me? Can I finish it?
Yes, I'm trying to make this point. It's important.
Going back to what I'm saying. If we have two objects in front of us and they're separated 5 feet apart, we have a big red fire truck 5 feet tall in front of us, and we have 5 feet separation up above. There's another big fire truck. They're moving in parallel lines away from us. But at some point, they will converge. Some point.
Only because
Let me finish. Now, I can calculate that, Scott. I can calculate it using arithmetic. Yeah. That is basically showing the two objects are not touching each other, but only appearing to touch, right? So in the same regard, can you just, are you ADD kid or something, dude? Can you just
dude, I hate to break it to you, but you interrupted me crazy when I was trying to talk, so I don't know what you're complaining about.
Well, why don't you lead by example then?
I did last time, and that was what got me. It got me you interrupting me after I didn't.
He's melting.
Okay. Yeah, I know. So listen, dude, you know that those two fire trucks, as they move away in straight lines from the observer, they will never touch, right?
Not in real life, no. So do you know that this is
not
relevant
hold on,
to what we were just talking about?
Not in real life, okay? But it will appear to converge into one, wouldn't it?
At some point, the Rayleigh criteria kicks in. You can't distinguish between them.
Okay, so I'm going to give you a calculation. Let's say we have a 5.
Why? What are you talking about?
We have a 5-foot truck. We have a 5-foot truck. We have one below us.
He wants to prove he knows the Rayleigh criterion. Right?
No, I'm going to give you.
Wavelength of light and distance. I mean, what's
it has
the
nothing
point?
to do with what we just discussed.
Who cares?
I'm going to give you a quick calculation without getting
you
into
told me the calculation for Rayleigh criteria has nothing to do with what we're talking about.
The convergence, the apparent junction, is what we're talking about.
That's not a convergence.
That's not the same thing.
Junction.
These guys, listen, man, I'm wasting my time with these guys. Listen, you guys are obvious gatekeepers. It's
do you
all
think
good.
do you recognize the horizon?
You're obvious.
The horizon's not a point.
Do you recognize the horizon is a mere 3 miles away?
You're bad for humanity because I'm giving
you a
practical...
recognize the horizon is a mere 3 miles away sometimes?
I'm giving you a practical observation that highlights the junction, the apparent junction, proving my point that it's caused by refraction and your angular limitation.
I'm just asking a question, dude. Do you recognize the horizon 3 miles away sometimes?
The apparent junction.
It should be 3 miles away all the time, bro. All the time.
Okay, well,
but we falsified
Thank you for answering honestly. Thank you for answering honestly.
Falsified
now, think about this. You're going to tell me that 3 miles away the Rayleigh criteria is kicking in? You're going to tell me that 3 miles away the Rayleigh criteria is kicking in?
So I'll give you an example. That's why I'm giving you another formula.
Question for you.
I'm giving you
a question. You know what I'm noticing, Flat Earth Data? I'm noticing that you like to talk, but you don't like to answer questions.
I'll give you a formula that highlights the vanishing point.
I don't want a formula, buddy. I don't want it. I want you to answer questions or have a real conversation. What you're doing is waiting for me to finish talking, and then you start lecturing about some new topic.
I'm on the same topic. I haven't changed, bro. It's all
well, listen. Let me tell you something. There are two ways to divide up computation, okay? There's polynomial time computation, and there's also computation that you can test in polynomial time. So we call these things P
so
and
now
NP.
we're talking about polynomial times. Dude, apparent junction of the sky and ground, the convergence focus, bud. The appearance of the appearance of the ground, the appearance of the ground appearing to rise. It's not really rising. You already said that. In fact, what you said is actually dropping away. So if it's dropping away, how do you know it's dropping away?
So P equals NP is a question. Is polynomial time computation the same as computation that you can test in non-polynomial
You broke
time?
him.
Yeah,
that's a question.
You're done. Yeah.
I'm making a point, Flat Earth Data. And you know what the point is? The point is that's what you're doing. You're ignoring everything said to you.
This is what you did.
You're ignoring everything said to you.
This is what you did.
And then you're just randomly talking about things you want to talk about. Rather than answer the questions being directed to you.
This is what you did.
Being honest and ingenuous. But instead, you're acting like a troll. So again, I'll ask you, do you recognize that the horizon is 3 miles away or not?
This is what you did. And you're documenting.
Can you recognize that?
You told me the ground.
Can you recognize that?
You told me that the ground doesn't rise. In fact, it drops away. It only appears to rise, you said. This is what you said.
You recognize the distance to rise.
You were written down and documented in 2021 at 1:59 a.m. that you said the ground doesn't rise. It only appears to, and in fact, it drops away. This is
what I have written down for you. I have in 2021 Flat Earth Data questions he answered, and the page is blank. There's nothing on my page. I can't write anything down because you don't ever actually engage in a conversation.
Buy my book. You're in it.
I will promise you, I will not be that excited or interested, but I'm sure someone will show it to me, and I'm sure I'll read it. I'm sure it'll be fascinating. But again, you really do you not recognize that you do this? Are you seriously completely unaware of the fact that you're not engaging in a real conversation?
To clarify,
like listen to you right now. As soon as I start talking, you start over talking me, and as soon as I'm done, you're not going to care what I said. You're going to start giving a lecture on whatever it is that you want to say. What you do, I've noticed, is you have a couple of things that you've studied more, than other people, or you have a good handle on. So you just pivot to those things. Every time you get a hard question, you just start talking about Rayleigh criteria. like as if that's somehow going to be an answer.
I've never deviated from the conversation. It's always been about the apparent junction. I told you I was going to offer you another formula that was nothing to do with Rayleigh criterion, but under the same principle.
Okay. But do you feel ready to answer the question?
It's based on our vision, which you do not want to handle.
Well, do you want to answer some questions yet, or do you feel ready to do that?
This is why you answered this answer. You said the ground doesn't
answer
rise;
or
it only appears to rise. The ground doesn't rise; it only appears to rise, and in fact, it drops away. That's literally what you said.
That's literally true. You know how, and you know what? That's me answering a question. Now, why won't you do that?
We're talking about perspective and the conjunction point. So if you want to deviate from that conversation.
No, my question is about the horizon. That's what we're talking about, right? The junction point, the horizon.
So the horizon is.
So are you willing to answer a question or not, Flat Earth Data? Why is it just so allergic to answering questions?
Well, go ahead. Try me out. Let's do it.
Oh, okay. Wow, how generous. So do you recognize that sometimes the horizon is as close as, say, 3 miles away?
No, I've never actually measured it.
So you don't think that's true, or that's not something you could accept?
I've never actually measured it.
So what does that mean? That means you have no idea how far away it is?
I do know that we can see a much farther away than your Earth curvature calculator has measured it. But as far as but I'm giving you an answer.
Okay. Go ahead.
I gave it to you.
So do you recognize then that the horizon can be close? Like say 3 miles away. You said you didn't.
So according to your Earth curvature calculators, it claims that it's 3 miles away. Sometimes. But I haven't measured that particular thing. What I have measured is that at 1 foot observer, the horizon is much farther than 3 miles away. That's what I have measured.
How far away would you say it is?
So the horizon is an apparent position based on an angular limit. That angular limit is relative to what optics is being used, whether it's camera or whether it's human vision.
You said with naked eye.
So the naked eye, well, depending on weather and conditions, from what I understand, there's a junction there roughly 3 miles away. But that junction is not based on Earth curve. It's based on your angular limit for being
Why did you just tell me no a minute ago then?
For what?
I said, do you recognize the horizon is sometimes as close as 3 miles away? You said, no, I've never measured that.
I haven't personally measured it, but based on your Earth calculations, that's what it says it is.
Okay. So if it's something that's 3 miles away, we're looking at something that's 3 miles in the distance. Do you tell me how your intuition tells you that the Rayleigh criteria could have any bearing on what we're going to see?
So how your vision works is basically the angle of light bouncing off that object to the eye. Now, if you have a large object, you're going to be able to see it farther away. But at the end of the day, there's a junction there based on a limitation of that angle of light reaching the eye. If you increase that angle, you can see farther. If you shorten that angle, you can only see closer. This is demonstratable by looking down a long hallway. The convergence and junction point happens much sooner because you have smaller angles. So your horizon is dependent on your angle to it. In other words, you increase, let me finish. You increase your height, the ground extends outward like an L, if you will. So it's like an increasing L as you go up. You already established the ground doesn't rise. It only appears to rise. So if I'm increasing my height elevation, the tangent line increases outward. I get a more increased tangent line the higher I go. But since
you also see beyond the curve.
Let me finish. Now,
you realize you don't get interrupted anywhere near as much as you interrupt.
Now, when the ground appears to rise, it's based on our eyesight. But initially, as we increase in height, we increase the L.
What you also do is change your angle to CB things that were obstructed before.
You open your angle, yeah. You can see more things. Yeah.
The things that were obstructed. If it was indeed true that the horizon was flat or the ground was flat, then the horizon would not stop at apparently 3 miles ever.
Okay, so the only way to get a horizontal position is to having equal points of elevation everywhere you go, and that's only possible on a plane.
So That's not true. You're going to have equal points of elevation if elevation is defined as distance from the center.
The only way to get a horizontal pathway is having equal points of elevation all around you.
We don't have horizontal pathways.
That's only possible on a plane.
Sure,
Now, if you tell me, now if you tell me you're a little ant and the Earth is really big and therefore it appears flat, then how are you measuring Earth curve being a little ant?
We're using
on a
instruments.
massive sphere. Oh, using instruments. Those instruments are what?
Hold on, listen, why do you interrupt so much and then complain whenever you get interrupted? Yeah, we use instruments, and we use all kinds of different instruments. We get perspective changes. We use ways to measure how shadows are falling on things. But again, you just completely glossed over my question to you, which was, if the horizon is 3 miles away, and if it was actually a flat plane of any kind, then why would we perceive the horizon to not be further away? Why does it stop at 3? There's nothing about the Rayleigh criteria or about a flat plane that would suggest that it stops and appears to have a junction at 3 miles away. We continue to see apparently going on forever.
If I lower my head to the ground, the angle to the ground gets narrower and the object in the distance gets closer because the angle gets narrower.
Farther away.
When you get closer to the ground,
the object. If it's a taller object, we still can see it.
When you get 1 foot off the ground, your model claims the horizon is 1.22459 miles away.
Yes, that's right. That's because our angle to beyond the curve is different.
So
but your angle to the ground is actually making it seem farther away, right?
Just here, I have another great question for you. So just to clarify,
so you're not answering ours, but you're going to ask more of yours.
You and me, 1 foot off the ground. You're telling me you're telling me your horizon.
I thought you were an ant.
Your horizon is 1.22459 miles away.
I thought you were an ant.
Everything is going over that, correct?
I thought you were an ant.
Well, that's the horizon. On your geometrical ball, you have geometrical calculations that says that's the edge of the sphere, because how do you calculate a sphere? You calculate its drop. Well, that drop has parameters.
Well, that's not really how you calculate
at 1 foot, the drop's going to begin at 1.22 miles. And at 2 feet,
the drop begins right away, dude. Listen, you get so many.
Let me finish.
Hold on. The drop continues right away. It's not how you measure the sphere, but yes, the horizon will be at that distance.
Yeah. So if you add refraction 20%, you've got 1 mile at 1.32 miles.
Is that
the refracted. Once you guys understand that you can see past both those calculations, you have to realize that it's not a geometrical calculation anymore, because
it means refraction was more than 20%.
I'm sorry?
We can't, or if we can, it means the refraction was more than 20%.
Right. So refraction is causing the Earth to appear flat?
Is that how it happens?
Absolutely.
Okay, yes. The refraction. So how do you get refraction again?
Can you prove an answer?
You need straight lines, right?
Well, you don't need straight lines. It can curve. But
how do you have straight lines? How do you have straight lines of light?
You keep interrupting. Every time anyone talks, you have to start talking. The different densities of the medium, when they're abutted and the light's passing between that barrier, that's when it turns. That's what it angles. That's when you refract. If that's happening in a continuous fashion, you're going to get a curve.
So straight lines of light is what you need to make bendy light.
No, I just told you the answer to that's no.
Okay, can you demonstrate bendy light being refracted then?
Yes, I just told you. If the density is changing continuously, then what's going to happen is it's going to curve. So it's a continuous function. It becomes you can model it as a curve. It looks exactly like a curve. There's no straightness to it.
So we're seeing refraction.
Can you demonstrate you're an ant?
So we're seeing refraction, right? And
not demonstrate you're an ant?
Well, sometimes refraction will loom the horizon up, so you'll see a horizon that is being loomed because of refraction.
So
you can see flatter than it actually is.
So the ground doesn't rise, but only appears to rise, and it's actually dipping away. Noted. Now you're saying, yeah, go ahead. Sorry.
Real quick, okay. I just want to just take note that an autistic retard had said about 12 times, "Are you an ant?" And it was clearly.
That was really nice.
He keeps on claiming that ants can do this and ants can do that, and I'm just wondering if he's an ant.
I'm sized like an ant is on a smaller ball.
So you think that you're this tiny person that you are on a massive extended plane? You think you can measure Earth curve by negating perspective?
It's not a massive extended plane.
It's not a massive plane. Are you sure about that, Scott?
It's a massive sphere.
So, but we observe it as a plane, right? We don't observe a sphere, do we?
Truthfully, we observe it as a sphere because we've used tools and we've changed our perspective.
Truthfully, we observe it as a sphere.
Yeah.
But yet,
when you look at all the observations we have,
you
look at all the data that you've taken your observation is that it's a sphere.
So hold on. We have a horizontal pathway of vision, which means equal points of elevation all around us. Where is the sphere in that?
What do you mean, where's the sphere? It is the sphere. When we see the horizon below, listen, I'm answering the question, stop interrupting. When we see the horizon below our eye line, it's telling us that we are on a sphere. When we change our perspective and see that it's a sphere, we know we're on a sphere.
Scott,
and by the way, we know also that when we just casually look around, what we're seeing is consistent with a flat plane and also consistent with a sphere that's very large. So anyone smart knows, well, I can't distinguish between those two yet. I need better observations. And when you get them, it then carves away flat plane.
Scott, what's the circumference of a 6-foot observer standing on the Earth?
What is the circumference of a 6 feet?
I'm convinced you're an ant, mate. Really, I really am.
Oh, like 3 miles, 3 miles ish.
Well, the radius is 3 miles. What's the circumference?
2 pi r. So 2 pi 3.
18 miles. So if a 6-foot observer looks in a 360 degrees and he's only seeing an 18-mile circumference, are you telling me that is you living on a sphere? And that's what you're using? Yeah. 18 miles? 18 miles? Have you guys been ever in a plane 5,000 feet? Can I see the radius and circumference of a 6-foot observer at 5,000 feet?
You're an ant, mate. I've never seen a plane.
You way more.
Exactly.
You go into space.
So do I see the apparent junction the 6-foot observer sees on the ground?
See a different one.
Or do I? Oh, the horizon's personal. So it's apparent, right? Based on your angular limit, right?
No, based on where you're standing,
right? Yeah.
Obviously,
based on
perspective. Otherwise, we just have one horizon that's universal.
So at 5,000 feet, I can look down at that 6-foot person and see his 18-mile circumference plus his 3-mile radius where the apparent junction happens, because you said the horizon's at 3 miles, right? But when I'm looking down, when I'm looking down at that observer, the land is completely level for another 10 miles, another 5 miles, easy.
That's not true.
But the 6-foot observer that you claim you are is able to measure dip drop, right?
Yeah. Right? Typically, you want to be higher than 6 feet in order to get a measurement because you need something really accurate.
Okay.
But if you're at 400 feet, you're at 400 feet, you can measure it pretty easily.
So a 6-foot person with 3-mile radius with an 18-mile circumference is able to measure dip or drop of the Earth you live on.
What did I just say? It's like you don't listen. I would say, really, if you want to be able to measure it in casual sense, like you and me go measure it, then I would say 400 feet is where you need to be at least.
400 feet in the air is where you need it. So why is everybody trying to measure at 6 feet?
Well, they're measuring something different at 6 feet. They're usually looking for obstruction.
They're measuring something different at 6 feet.
Yes, they're usually looking for obstruction.
So 6 feet is obstruction and 400 feet is what?
Well, if you want to find the dip of the horizon compared to your eye line or compared to sort of the directly ahead of you, then you can do that around 400 feet. It starts to separate out enough that you can measure it with a casual instrument.
Okay,
you're going to need something really precise to do it at 6 feet.
So no sextant has measured a dip on the ocean?
Maybe there's a really good sextant out there that I'm not aware of, but 400 feet is where you want to be.
Oh, that's so good, man. So
I don't know what you think is so good. It's a really straightforward answer, dude.
Yeah, the only way to get a horizontal path is equal elevation. That's only possible on a plane.
Okay, listen. Equal elevation happens because of the distance to the center. The horizontal path is a myth. Like you don't actually have it. The path is curving on the surface of the Earth. When we go higher, the horizon
it's a myth.
It is out for the person. Yeah.
So do we measure in spherical geometry or do we measure in Euclidean geometry?
It's like you cannot stand it. The horizon gets extended out the higher you go.
You're just real cringy, man.
Get triggered every time.
You're real cringy. That's all. That's all I have to say.
You can't help yourself. You just really, really can't stand hearing anyone else have anything to say.
What do you get paid to do this? Is it for script, writing a movie? What are you doing?
What do you think I get paid?
Well, it's got to be in the script, man. You got to have somebody want to write a script and get all this information.
Who in the world would spend money on this Discord? What are you talking about? Do you really think you're so important that you
Microsoft is buying this? Microsoft is buying this.
Veach, get in there and tie Flatter's dad up because he's scaring the hell out of us.
Of course, he's a total narcissist.
Get a grip.
Microsoft is buying.
He's a total narcissist. What do you expect him to say?
Microsoft is buying Discord for $10 billion, right? No, the point is you. look, you claim to have evidence of space. You claim to have all this evidence, but you go out of your way to fight against flat Earth. So I'm here.
I don't really go out of my way. I like to talk about science. And when you come in here, people like you, and you ask questions, you get answers, and then you end up saying something wrong. Then we just very politely, I try to just say, oh, hey, actually, I think that's wrong. I start to tell you. And then you start to spin out, and it gets like this. But this is because of your personality, not because of the fact you're a flat earther. I mean, I happen to think you're wrong. I don't think it's bad that you're a flat earther. I don't think you should have to change your mind. If you want to be a flat earther, you have my blessing. It's not a big deal. It's not hurting anybody. Flat earthers are fine.
You literally said the ground doesn't rise, but only appears to, but actually dips away.
Yes, exactly right.
So, but it appears to rise into the neutral point, but it doesn't actually rise between two observers. It only appears to have an injunction.
Rising, because from your perspective, it's dropping away.
Where does the dip come into play?
Which dip? The dip to the horizon?
Well, you just said the ground doesn't rise.
Yeah, it doesn't rise at a rate fast enough.
It actually dips away, right?
Because it dips away starting right away. Okay, so right away it's dipping, but because of the way perspective works, that appears to rise because your perspective is making it rise faster than it's actually dipping. But it does hit a limit where the horizon is, and it stops rising at that point.
You just said
that will be below.
Makes it rise before the dipping.
Yeah, you're back on
the face. Funny. It's like the only argument you really have is the giggle. But
this is great.
You're back on the safe space now, aren't you? That's good.
So anyways, I'll say it again.
Nathan, did you hear
I'll
that?
say it again. I'll say it again. You don't worry, you can record it if you want. So
did you hear that?
Perspective causes things to appear to rise, right? That happens at a certain rate.
Hold on.
You don't want to interrupt. You want to get it clean. You want to get it clean, Flatter. You want to get it clean
faster than the
maybe put yourself on mute if you need to, so that I can get it out clean and you can have it and you'll giggle to all end. So the perspective that you have that things are rising, that's happening at some rate, right? And it has to happen at a rate. Otherwise, I mean, it just doesn't make any sense. The more things are extended out, the higher they appear to be, and there's a relationship, a ratio between those two things. Now, point of fact. The ground is actually dipping away from you. It also has a rate. Now, if the ground dipped away from you at a steep angle of 45 degrees, you would not perceive that it rises really. Technically, it would rise relative to what it's really doing, but you would never have the sense that it's rising in your vision, right? The fact that it's almost flat, just barely dipping away from you, makes it seem as if it's rising as you look at it up to a certain point. It's not hard. It's not funny. It's not that giggly, I don't think. That's how it works.
Oh, this is what I wrote down.
No, well, he wanted to get away from his safe. He wanted to get back into his safe
No, I
space.
laughed. I'll tell you why I laughed.
Alden, as soon as you got back onto your safe space, you could have a little giggle. That's why.
I'll tell you why I laughed. This is what you said.
It was nothing to do with what Veach said. It was because you're back in your safe space.
Listen, I wrote it down.
Oh, perspective happens. On the book again. Here we go.
Perspective happens at a faster pace than Earth dipping away. That's what you said.
Okay. Yeah, that worked.
Awesome.
That worked. It's casual
language.
It's casual language, Flat, but you understand what I'm getting at.
Perspective happens. Well, this is what you said. The ground doesn't rise, but only appears to rise, and actually dips away. Perspective happens faster at a faster pace than the Earth dipping away. That's it. I'm just here to document it, man. If that's what you believe, you're allowed.
That's fine. So it's casual language. Presumably, you can interpret what that means. I've just explained it to you.